Welcome back to episode 4. I can't believe you're still here. I'm just kidding. In the last video, we looked at how to make a graph, just a regular old graph from your data. In this video, we're going to adjust your data so that we can plot a linearized graph of any curved graph that your data has displayed previously. Which means we're going to modify some of our x values as well as changing some of the errors in our x-axis because we modified the x-axis data. Let's get started. Let's zoom in. In our lessons and also from the model itself, you can see how the equation that best fits this line or the model of this graph is roughly something that looks like y equals to the square root of x. If I have to display x as an exponent, I have y is equal to x to the power of a half. This means this will dictate what I will do to all my length values, to all my x values, which is the length. From our linearization 1.12 lesson, I believe it's 1.12, we looked at how to take all our x values and apply the same exponent as our function, which is exactly what I'll do here. I know that I need to take all my x values and I need to take it to the power of half, or I square root them. So I'm going to write here square root of length. And for my units, I will make sure they are appropriate. This is meters to the power of a half, because my dimensions have changed after I've square rooted my length values. Give this a different color just to show that it has some amount of importance. Now here we're going to enter our function, or what we're going to do with our data. Because we're entering a function, equal sign. I am going to now put in this new, I'm going to use the length that I had before, that's my x. And I'm going to give an exponent, which is the power of a half, because you can't really put a square root on Excel. It doesn't quite recognize the language. So we're going to use the exponent. To put an exponent, it is a little hat. The hat is shift 6, you get a little hat. To put in a half, I can either type 1/2 in brackets, or I'm going to put 0.5. It's easier because it also means a half. Enter, and that gives me the square root of my length. I want more of these values, so I'm going to go to the side here to the right lower bottom corner where I get the black cross. I click and drag, let go. It gives me the square root of my length for all of these data points here. Of course, I'm going to need appropriate significant figures, and it seems like it's going to be roughly about the same, about 4 decimal places, similar to what we have before. Format cells, number, and not 15. That's crazy. 4 decimal places. Here we have it. Taking the square root of your length. Now, we need to adjust the uncertainties accordingly. So I'm going to include one column for the uncertainty of length so I can actually work with this. You know what? I might not do that. I'm actually going to show you something else. Something else that's really cool. I'm going to show you how to refer to one cell even though you're going from row to row. I'm going to put this graph over here so I can show you a little better. Before we do anything, we have to figure out what we need to do with our uncertainties. So recall from 1.14, uncertainty propagation is whenever you're taking a value, the value, to an exponent, you need to first find the relative uncertainty. To find the uncertainty of our newly adjusted length values, so I'm going to call this y, to find delta y, which is the absolute uncertainty of the square root of length, we need to look back at length because we did something to length. We square rooted all these values. I'm going to call length here a. And I'm going to call this uncertainty here delta A for it being the absolute uncertainty of length. What we did was we took the square root of all our A values to get our new Y's. Our delta Y's, or actually let's call this the relative uncertainty of our delta Y's, the relative uncertainty of our square root of length. This is equal to the relative uncertainty of our length, delta A over A, times a half, because a half is the exponent for square root. This was mentioned in 4.14 in uncertainty propagation. Now we have the relative uncertainty of y. We want to get the absolute uncertainty of y here in this next new column. To do that, we simply take this above and we multiply this by y itself. So in our total function, when we put in our function, we're gonna need this value here, we're gonna need these a values over here, and we're gonna need these new y values over here as well. We're gonna need to use all three of them. This is where things get a little interesting. But before this new thing, I'm gonna put in a title for my axes, or my column. It's gonna be long square root length uncertainty. Units are meters to the power of 0.5 because I'm lazy. And I'm going to make this color code slightly green to make it the attached to this guy over here. Okay, so this is what I'm going to do. I am going to enter a function. In the past, when we took a function with a cell reference, G4 in this case, and we clicked on the black cross, dragged, and dropped down below, what happens is that Excel automatically knows to use the next cell down the column. Excel is smart that way, but Excel is not always that smart. Here, let me show you why. If I press equals, and I'm going to enter exactly this function here. To do that, I'm going to take delta A, which is this guy here. I'm going to click this guy, go back to the thing. Click this, which is delta A. Okay, here, let me write it a little bit beside it. So this is delta A, this is A, and delta A is this over here, okay, according to this down below, this equation. I need to divide this by A, which is this guy here. That's my first the one in my first column, in my first row. I'm going to multiply by a half, and multiply is the little star, which is shift 8, gives me the star. I'm going to multiply by half. I'm going to put 0.5 instead of 1/2. It's a little easier. And I'm going to multiply by y. So again, shift 8 gives me the star. I click on my y, which is the square root of length. Okay, and that should be it, right? So I click enter. It looks fine as of right now. It looks small enough to me, but let's drag and drop, see what happens. Click, drag, and drop. Oh, okay, that's kind of weird. Don't know why it does that, hey? So let's go to the next cell and see what happened. Notice that the C15 reference is empty. Excel is smart but dumb at the same time. It looks at the next following cell even if I go down the row. So if I go to the next cell, it looks at C16. So it assumes that there's a separate column down here with a bunch of values that I've referenced to, similar to the square root of length. Because if you take a look here, the square root of length was referenced properly. The I5 as well as the A5. So it keeps going down row by row. But the thing is, I want this reference to stay put. How do I get this reference to stay put? Because I want to use a cell every single time when I'm calculating from row to row. How do I do that? There is a cool thing you can do. I'm going to go back to my formula bar and I'm going to put in something else. Or I'm going to put in something extra. C14 is a cell I've been referencing. It's the cell that I want to hold still. If I want the cell to hold still when I drag and drop, what I'm going to do is I'm going to put what's called a $sign. So I'm going to put a $sign in front of my C, the letter, and I'm going to put a $sign in front of the 14, which is my number. So think of dollars. You want to keep your dollars because money is good to have to buy lunch, whatever. Something to help you remember is a $sign that allows you to hold the reference still, even if you drag and drop. Even if if I enter the $sign, the calculation doesn't change in my first cell. But now if I click on my cell and press on the little black cross, drag and drop, bingo, it doesn't change. Notice the next one, $C, $14. Next one again, $C, $14, and etc. But everything else changes as it goes down the row. My A9 and my I9, those are properly referenced, and etc. A10, I10, except for the $C, $14. So that is how you propagate your error on your uncertainty. And I showed you something else, which is holding a cell reference even if you drag and drop. Now you have the new x's and the new uncertainties for the x's to make your graph. In fact, what I'm going to do is I'm going to stop this video here and make a separate video just for completing the graph. That video, in fact, you may may or may not need to watch if you already know what you're doing, because it should be a recap on everything we've done, except maybe looking at different functions. But if you're interested, stay tuned for episode 5. The recap for this one is we looked at doing error propagation on Excel. The next video we will touch base on how to make the graph. And episode 6 is going to be on making max-min slopes. Imagine that I'm putting a filler episode to get more money off of my viewers. No, I'm just kidding. No, I just want to make sure this video is short. It's been a long time. Anyway, stay tuned till episode 5 for making the linearized graph. Thank you for watching. Hopefully you got something out of that. Bye and see you next time.